In this video, we're going to go over section 1.5 from our textbook, so solving linear equations and their inequalities. So first, we'll look at this example here. Suppose we're asked to find the zero of this equation here. You remember from, I think, 2 videos ago, the zero is also called the root or the x-intercept. And if you remember, we can find that by setting our y or our function equal to 0. So we'll set that equal to 0 and solve for x. So we'll take away 12 on both sides. So we get negative 3x is equal to negative 12. And then we'll divide by negative 3 on both sides to get x completely alone. So we get negative 12 over negative 3, so that'll be positive 4. And this is our x-intercept, our root, or our zero of our function. And on your homework, I believe if you're asked to find the zero of a function, you'll just enter it as this. So like for this exact example, if you found the zero was 4, you just enter 4. And then when it asks for the x-intercept, you'll enter it as an ordered pair. So 4, 0. We get that x is 0 when y, or sorry, we get that x is 4 when y is 0. All right. Another thing you might see in the homework is if you're just given the graph of your function and you're asked to find the zero. Well, what you can do here is just look at your graph and see where it intersects the x-axis, because the zero is also our x-intercept. And looking at this graph, we see it happens right here at this point, which is negative 1, 0. So the zero of our function is when x is equal to negative 1, then our x-intercept is negative 1, 0. All right. So for this example, what we want to do is solve this linear equation. And what we mean by that is to solve for x. So we'll do some algebra here. First thing we'll do is kind of multiply everything out, simplify, see if anything's cancel. So the first thing I'll do is I will multiply or distribute the 7 to x and 3. So we get 7x plus 21. 7 times 3 is 21. And we're still dividing by 4. Then on the right-hand side of our equation, I'm going to distribute this 1/2 to both of these terms here. So we get 4 over 2, so that's just going to be 2, minus x over 2. Right? The next thing we can do is we can multiply both sides by 4 to get rid of this fraction on this side. So these 4's will cancel, and we get 7x plus 21, and then we'll need to distribute this 4 to every term here. So 4 times 2, we're going to get 8, and then we have 4 divided by 2, so then we just get 2x. And so this is way better than our original equation here. What we'll want to do is combine all of our like terms. So I will add 2x on both sides, so our x's are together. But then we'll get 7x plus 2x, so that'll be 9x. And then we still have our 21, and that'll be all equal to 8. Then we'll take away 21 from both sides, because remember we are still trying to solve for x. So we'll get 9x is equal to 8 minus 21, so that'll be negative 13. And then solving for x completely, we'll divide by 9 on both sides, and so we get x is equal to negative 13 over 9. And then for your homework again, if it asks for the solution set, we just write our answer in set notation, so using these squiggly brackets. And so for this particular example, your answer would be the negative 13 over 9 in the squiggly brackets here. All right, so the next thing we'll look at is solving an inequality and graphing it. And I did not write down the example here, but that's okay. We're going to look at the inequality 2x minus 7 is greater than negative 15 plus x. So what we want to do here is, again, solve for x. Let me actually move this onto the next page. Okay. So we want to solve for x in the same way that we did in the previous example. So the first thing I'll do is, again, look at like terms here. So we have a 2x on one side and an x on the other side. So I'll subtract out this x on both sides. So we get 2x minus x, so that's just positive x left over. Then we still have the negative 7, and that'll be greater than negative 15. So then we can add 7 to both sides, and then we get that x is greater than 8. All right, and then to graph this, we'll use a number line. And so let's say we have 0, 1, all the way up to 8. So in this case, x is strictly greater than 8, so we'll use a open parenthesis, and then it'll be all x values up to infinity. So that's what it would look like on graphed on a number line. All right, so the next example we're going to look at is solving a two-sided inequality. So we're going to solve it the same way we did the previous example, just by solving for x. But in this case, we have 3 parts to our equation. And so whatever we do to one part, we're going to have to do to the other parts. What I mean by that is the first step to isolating x is I'm going to take away this 4 here. So 3x plus 4. So taking that away will leave us with 3x here. But when I subtract 4, I'm going to have to do it to this side and this side of our inequality. Doing so, I'll get negative 5 here. That'll be less than or equal to 3x, which is less than or equal to 0. All right. Now again, we want to completely isolate x, so we're going to divide by 3, and then whatever we do to that side, we're going to have to do to the other 2 parts. So then we'll get negative 5/3 on that side, and then just 0 on this side, because 0 divided by anything is just going to be 0. All right, so we're left with x is anything in between negative 5/3 and 0. So on our number line, we would graph this. Let's say we have 1, 0, negative 1 here, and we'll have negative 5/3 somewhere over here. When we graph this, we're going to use the closed brackets here because we have that x is greater than or equal to negative 5/3 and that it's less than or equal to 0. And so our x values is everything in between or equal to these guys. All right, so that's it for this video.